In this video, we're going to do some examples of percentage concentrations. So we'll go to our handout to do those. But what I do want to point out is that after each example that we see of different types, you'll see some pause, try, and play scenarios where there's some video examples done of the volume, mass, volume, and you can also try those out as extra practice problems to make sure you truly understand the concepts. So let's go ahead and try example number 1 and example number 2, which correspond to percent VV type problems. So we're doing our first type of percent concentration, which is a percent VV, volume, where your solvent and solute are both liquids, and we're going to treat them as liters and liters each, or milliliters and milliliters, as long as we're consistent. So example 1 here, 25 milliliters of the anesthetic is added to a certain amount of sterile water to make a total of 200 milliliter solution, of a 200 milliliter solution. What is the volume percent VV of the anesthetic solution? So all we're looking for here is the percent VV, so percent volume is going to be equal to the volume of our solute over the volume of our solution. And that's a total solution, the volume of the total solution there, times 100%. So we're going to do 25 mils over 200 milliliters. Now I know it says liters and liters, but as long as we're consistent here, milliliters and liters, we're okay. Times 100%. And we're going to get, so we have 25 divided by 200 times 100. And we get approximately 12.5% VV. Milliliters are canceled out there. Now, don't forget, we do have to have that rounded to the correct number of sig figs. In this question, we only have one sig fig there. That's our smallest number. 25 is 2. So we'll make this about 12.5 can become 12. We won't want one sig fig. So basically, we can round this down to 10, approximately 10% VV, only because we need to round to one significant figure, just because our volume measurement here is not very precise with the instrument that we used. So start off by doing just a regular calculation, and then afterwards you can round to the correct number of sig figs, which is one significant figure in this particular question. So that was an example of percent VV. Let's go ahead and try another example here. We have rubbing alcohol is commonly used as an antiseptic for small cuts. It is sold as 70% VV solution isopropyl alcohol in water. What volume of isopropyl alcohol is used to make 500 mils of rubbing alcohol? So basically what we know is that we have our percent VV already given to us. So let's write out some given information. So given, we have percent VV is equal to 70%. And then just as a reminder, when I use it in the calculation, which you'll see I probably will need to do that here, I need to use that in the decimal form, so 0.70. Oops. 0.7, because there's one sig fig there. So one sig fig here. Now, what volume of isopropyl alcohol is used to make 500 mils of rubbing alcohol? So this 500 mils of rubbing alcohol corresponds to the volume, the total volume of the solution. Total volume of the solution. And that's going to be 500 milliliters. And so we know that 70% of the solution is alcohol. So basically, here's what we know. We know that the percent volume is equal to the volume of solute, which is our alcohol in this case, over the volume of the solution, which is the alcohol and the water together, which is the 500 mils. So we want to find the volume of the solute, which is our alcohol that we're dealing with. So we can rearrange that to get volume of our solute, the alcohol, is equal to the percent VV multiplied by the total volume of the solution. So this is our step 1, write down your given information. Step 2, write down your formula and rearrange. And then step 3, let's actually plug all that stuff in. So the volume of the solute is equal to 0.7 times 500 mils. So 0.7 times 500 mils, which is about 350 milliliters. So this is how much alcohol you would need to make that solution, the total solution. So you have 350 mils of alcohol, and the rest would be water. So if you had to find, this is an aside here, just an aside. Let's say you want to know the actual components of that bottle. Well, 350 mils is the alcohol. And then the rest, so 500 minus 350, so 150 mils would be the water. I know generally we say the one that's in the greater quantity is considered the solvent, and the one that's in the lesser quantity is considered the solute, which is technically true, but we look at the consumer products in terms of sort of what the active ingredient is, and so that's going to be our solute, the alcohol over here. 350 mils of alcohol. Now, don't forget that we do need to make this according to the proper number of sig figs. So based on significant figures, we would be looking at, we'd have to round up to 400 milliliters for 1 sig fig. In reality, this should have probably been listed as, for example, 500 point for 3 sig figs. And then maybe over here, just 70% is our, you typically, if that's our percentage to 1 sig fig there, you'd also have to take that into consideration as well. When we're making consumer products, we have a better idea as to how much goes into it, so we can give a bit more trust to our percentage here. And since we can give a bit more trust to our percentage, generally we won't always look at that percentage for significant figure values. Though for calculation purposes in the science classroom, we do need to make sure that we are very precise with our significant figures to give us a better idea as to how these work out. So let's take a look at how vinegar is made. So here we have a vinegar, a volume percentage here, 5% acidity. So we have vinegar has a solute and a solvent. And so our solute for vinegar is going to be acetic acid. That's the actual acid that makes up vinegar. And then our solvent is going to be, well, water. And so we have 5 mils of acetic acid is mixed with 95 mils of water to make 100 mils of solution. So essentially, if we want to show what that would be in percent VV, we could simply do the percent VV is equal to 5 mils of the acetic acid over, not 95 here, because that's the mils of water. We need the total volume of the solution. So over 100 mils times 100%, cancel that out, and we get 5% VV. So that would be the concentration as a volume for vinegar that you would have in your home. So in this video, what we did is some examples for percent volume, where both our substances that we were dealing with were liquid, both the solute and the solvent. And then same thing over here, both the solute and the solvent were liquid. And we saw a nice practical example over here of something that you might have in your cupboard at home. Same thing with the isopropyl alcohol, the rubbing alcohol, you probably have that at home as well. And there's other anesthetics that you use that also have the percent VV listed on there. So take a look around your home. I mean, safely, of course. Make sure that you're not getting into anything dangerous. Ask your parents, guardians to guide you throughout, just to see if they've noticed anything that has percent volume on it, so you can see a practical application of this in your home. In the next video, we're going to take a look at how to do calculations with mass volume percent instead.